My name is Gregor.
My name is Joakim.
Yeah. Ocean traffic is far from a new phenomenon and has been a central part of human exploration for thousands of years. However, commercial motorized ferries have only become prevalent in recent decades, and their fuel expenditure is immense. The question to whether pollution emitted from these ferries is harmful or not is not a question that remains unanswered, but the extent to which this happens is not especially consistent. This study hopes to give clearance on how the Tromsø coast is affected by this.
Now, this study grapples on two subjects, pH value and heavy metals. For that, we need to know several things. Firstly, when it comes to pH value, what kind of pH value can be harmful to fish, and how sour must an environment be before fish start experiencing troubles? Well, the ranges in which fish have a more favorable environment is around 6.5 to 9.0, which is quite a wide range. So to expect something outside of that from this test would be unlikely. Additionally, heavy metals can be found in two different places when it comes to saying that they're in the ocean. They can be ionized in the ocean itself, or they can be in the sediments. Now, if they are in the sediments, they can be harmful to specifically bottom dwellers, like halibut and crab. If they're in the ocean itself, they can be harmful to normal fish, like cod. So we took two different tests to see what was affected by this. Now, how many heavy metals, or how concentrated the contents of heavy metals must be in the ocean to actually harm fish is studied a lot. And it's found that high amounts of iron and copper can harm fish by, for example, lowering muscle mass and crippling breathing capabilities. But to expect certain amounts of heavy metals that would be actually harmful to fish is also unexpected from this. Seeing as though Tromsø does have a lot of ferry traffic, it's not a lot compared to a lot of other places in the world.
To perform this study, we took samples from 3 different locations around Tromsø, from Frostneset, Telegrafbukta and Ramfjorden. There were 3 water samples and 1 sediment sample taken from each location, except from Ramfjorden, where we only took water samples. Acid levels were measured with a pH gauge in a classroom, while water temperature was recorded simultaneously. To test for iron, nickel, copper, lead, silver, tin, zinc, barium and calcium, we filtrated the sediments from the seawater. The sediments were then put in a beaker the sediments from Telegrafbukta were then put in a beaker with iron-free water for then nitric acid to be added to ionize the heavy metals from the sediments. The sediments from Frostneset were put in a beaker with nitric acid, and then iron-free water was poured over. The solution was then split into 5 test tubes for each location, so a total of 10 test tubes. Hydrogen chloride, dimethyl glyoxime, ammonia, potassium thiocyanate and sodium carbonate were then added, and the samples were left for around 24 hours at room temperature. The results show that there are quite consistent pH values across the board, with a slight dip in the levels at Frostneset. The precipitation reactions show a clear difference in the concentration of iron in the test tubes where potassium thiocyanate was added, which you can see here. The 5 test tubes on the right here are from Frostneset, and the 5 test tubes on the left are from Telegrafbukta. The test tubes which had ammonia added to them received a yellow-like color resembling canola oil, with a higher concentration of yellow color from the test tube from Frostneset. Additionally, the test tube from Telegrafbukta, where dimethyl glyoxime was added, had a white substance floating at the top.
Now, when it comes to the results of this, from the precipitation itself, we can assume that the samples mixed with ammonia and those mixed with dimethyl glyoxime are probably not that important. The one with ammonia showed a yellow-like color. However, ammonia is added to find copper, and copper makes a blue color, meaning that this is not relevant to the test. Additionally, the white substance found in the samples with dimethyl glyoxime are not important either. All heavy metals sink, so this is not really relevant to the test. Now the one mixed with potassium thiocyanate found iron, which was expected. Though the tests found in Verve, or Flosand, showed a clearly higher amount of iron than the one in Telegrafbukta, which makes it very probable that boating traffic does have an effect on heavy metals. However, if this amount is actually harmful to fish, is unlikely. The precipitation tests, although it showed a blood-like red color, they were still somewhat translucent, meaning that the iron contents aren't very high. The pH tests also don't really prove a threat to the fish. In Flosand, we took 2 tests, one at the ferry terminal and one at a nearby wharf. The one at the wharf found no real difference between the tests in Ramfjorden and Telegrafbukta. The one at the ferry terminal did show a somewhat more acidic value, though this was likely not due to ferry traffic, seeing as the wharf didn't show any of that. So we can essentially conclude from this that ferry traffic, at least in Tromsø, does not really affect the environment in which fish live. Not negatively, at least. Now, the sources of error, though there are some, they're not nearly substantial enough to actually incriminate this test at all. For example, the machinery and the materials that were used might have been dirty already. This might explain the yellow-like color in the precipitation, though this certainly did not affect the iron test at all. And other than that, there's really nothing to grab onto when it comes to sources of error. So this is likely a conclusive study and it concludes that ferry traffic doesn't negatively affect fish life.
Thank you.